The core problem in normalization is handled by two different methods, stemming and lemmatization. Let's look at some examples. Dogs make the best friends, and a dog makes a good friend. These are two statements that really mean the same things, but they have different wording. And there are common reasons for having variations of the same word. For example, nouns carry information about plurals in English, and we have different tenses of verbs and comparative and superlative forms of adjectives and adverbs. The big question for us is, can we normalize words to abstract away from such variations, such that these two things look more alike, and so their representations can be similar? Stemming is the first approach. How do we do stemming? Well, it's pretty simple. We design rules to do the chopping of prefixes and suffixes. These rules can be language dependent, and so people have come up with different stemmers that apply different rules even for the same language. For example, let's take a look at these raw strings and their stemmed outputs. Here we can see the S is removed away from cats and the ing is removed away from running appropriately, ending up in recognizable words. Because stemming applies crude chopping, sometimes we will get correct stems, but they don't look like words like presume and worse. And because there can be different stemmers that stem differently, we get alternations, such as here, phone with an E or without, or cry with a Y or an I. Because stemming uses crude rules, it's really fast and compact. There's no need to reference a dictionary or lexicon. But, of course, as we've already seen, things like presumably and worse get stemmed to tokens, but they don't look like dictionary words, which could have some problems when doing representation. The Porter stemmer is probably the most famous English stemmer that originated in the 1980s. It's a really simple, efficient algorithm that gets good results in practice, so you should get to be familiar with it. We'll have an exercise on it later on. For now, let's look at some of its rewrite rules. Here we have SSES goes to SS, so basically removing the ES at the end. And you can see how it works. Possesses changes to possess, and classes changes to class. The output of each pass when a rule fires is then run again to see whether other rules apply. That's why it happens iteratively. So this is especially important for long words like operationalize, where there are multiple suffixes that can be stemmed off. Some of these rules are more specific and require something like a look ahead or look behind. So for example, in this rule, a stem must contain a vowel. That means this part of the stem must have a vowel in it. So for example, singing and talking here work well because there's an A as well as an I. So we can stem the ing off in both cases. But the word sing by itself wouldn't be working here because the proposed stem doesn't have a vowel and just would be the letter S. Similarly, this one says that the stem must contain more than one character. So replacement gets stemmed to replac, but cement doesn't get stemmed because if we were to remove the E-M-E-N-T, we would just get the letter C. Can we do better than this? Yes, we can do lemmatization. Lemmatization reduces inflections or variant forms to a base form that you would find in a dictionary. These are called lemmas. We find the correct dictionary headword or lemma, and we reduce the form of the token to that form. One of the things that it does handle very well is if we know the part of speech, like a noun, verb, or adjective, we can stem appropriately. For example, if we're saying we saw the man run, it's a verb, and so even if we saw the man running, it would be stemmed to run. But if we said running track, maybe we would like to leave the adjectival form in a non-stemmed manner. It can deal with irregulars very well too, as we said earlier. Remember this example from stemming? It didn't work so well. But in lemmatization, we can get it down to the right form because we know exactly what the dictionary headword or lemma is. Some of the characteristics of lemmatization are the opposite of what you'd expect for stemming, right? You can see that we always get proper words out of lemmatization, and we can normalize irregular forms or tenses or numbers. Of course, there are some downsides too. It requires curated lexicons and lookup tables, and often requires that we part a speech tag first to get correct results. That's a little annoying because part of speech tagging is usually considered a downstream application of syntactic analysis. So to go back to lexical analysis after doing some syntactic analysis seems a little annoying. And because of all of these requirements, it's generally a bit slower than stemming. That might be not an issue if you're going to use the text over and over again, but for simple things that are only being used once, for example, user queries, it seems a little onerous to do this. Let's take a look at our motivating example again. Dogs make the best friends, and a dog makes a good friend. We said these are roughly semantically equivalent. We can see that the STEM version does a pretty good job, but definitely good and best are not put together, so these are a little farther apart. In the lemmatized version, we get these closer, so the lemmatized form does pull the representation of these two phrases closer together, probably a plus in whatever application we're considering. Finally, there are some practical considerations of normalization. The canonical form also affects the tokenization, so there's some back and forth between tokenization and normalization. For example, when we separate out clitics, for example, doesn't to does and not here, this affects the way we're going to canonicalize. We might keep hyphenated words together in tokenization, but that means when we're trying to apply normalization like stemming or lemmatization, we might not be able to undo the normalization properly for the first part of the hyphenated word. Other common normalization steps that you'll find may apply to English but also other languages. For example, the removal of stop words, which are common words that don't seem to convey much meaning. There are some cases of exceptions here, like not, which would be very important for sentiment analysis. The removal of non-standard tokens is also a common one. For example, removing URLs, emojis, or emoticons. Or sometimes task-dependent steps. For example, in dealing with social media, maybe we really don't care whether you have 3 question marks, and having a single one is fine.